Hi, folks. Welcome to the 1st of September 2025 in the Embedded Special Interest Group in the Bytecode Alliance. We're going to be talking about how the group works. We've got a new member who's come along. Welcome. And we're going to go through, just do some general introductions and then cover the topics at hand, which is long-term support and what we were talking about there. There's only 3 of us on the call today because it is Labor Day in the US, so attendees will be low. But this means that there's just the 3 of us and we can have an in-depth conversation about anything that we desire, which is pretty cool. So for a quick recap for everybody new to the Bytecode Alliance and folks watching the video when it's posted to YouTube, how we try to run it is we try to make sure we have people from all over the world who can participate in the Embedded Special Interest Group, or the SIG. We try to do it in a rotating fashion so that we've broken the world up into 3 time zones: the USA, Europe, and Asia Pacific. And we try to make sure that at least 2 of the time zones can meet. So if it's Europe and Asia Pacific, and then 2 weeks later, it'll be Asia Pacific, USA. And then 2 weeks after that, it'll be it'll be USA and Europe. And then it will rotate down. So everybody has a chance to talk. And there's always, or the hope is, there's always one person from the last time zone in the next meeting. So we have an overlap of people. It's hard to get everybody together in one big group, which can be quite frustrating. But this is kind of a compromise which works for most of the stuff. The rest of the conversations can take place via GitHub issues. We've been using some Google documents to discuss the long-term support question, and I will go through that today. The other thing we do is there is a mailing list. You're welcome to join it. Just let me know, send me an email address, and I'll add it to it. There's also a Zulip conversation on the Bytecode Alliance's Zulip channel. All things embedded related, and folks sit on that too. There's almost too many ways to talk to people, and sometimes things get missed. And the rough rule of thumb is if you don't get the right person, you probably will get them via email, worst case scenario. So that's kind of how it works. Today, we were going to cover the last major topic, which I understand was LTS, and there was some discussion about what that meant and what that is. We have a Word document about that, and I'm very happy to give another recap into that and where we are in it, what the comments are. And I will be sharing the link to the document. It hasn't changed from the last meeting, but I will post it up just for making sure everybody's got it. Give me 2 seconds. I will dig it out of my browser address bar, and I will drop it in the conversation, and it should be, or this will be a reminder to me when I upload the video to put the link in the video description for folks who are following along later. So that's roughly what we're going to do. What is long-term support? So long-term support is talking about how we provide support for tool chains and runtime environments for the embedded community. The embedded community is kind of different to the cloud community because it's not always possible for us to just upgrade and change our runtimes. We might have baked them into a ROM image and it's kind of locked in, or we've a large installed base of runtimes which is now on other people's equipment, and we can't update that. So we have to support those runtimes for a longer period of time. As new features get added to WebAssembly, or new features get added to WASI, the older runtimes might not support all those functionality. So we could end up in a situation where when we use the latest version of the toolchain, the WebAssembly it compiles is valid WebAssembly for the latest runtimes, but won't actually execute all on the older runtimes. So we have this mismatch. The other thing that we see is that one of the core values of WebAssembly in the web is the ability to bring code from other execution environments to the browser world. And it's a key advantage of WebAssembly in the embedded world that we can take code that's written for, say, a Linux environment or a POSIX-like environment, and we can bring that into the embedded world. And to make that portable, we need a robust and fairly secure and, well, fairly robust, wide Linux or POSIX-like API, just for portability of software. And the LTS has been looking at how to provide that support. We know that the folks in the WASI community, so WebAssembly breaks down into core WebAssembly, which is your web-based bytecode format, and that's one set of stuff. And then when it comes to running WebAssembly outside of the browser, you need a system interface, and that's coming from the WASI community. And the WASI community has a fairly strong view on Preview 2 and Preview 3 and beyond of adopting a component model, which is a different way of binding functions and doing foreign function interfaces. But then they also define a different set of APIs. So they're spending time to create HTTP interfaces and database interfaces for the workload that they're supporting, which is mainly in the cloud. On the embedded side, we still need things around threading APIs or signal handling for system integration or shared memory for system integration. So there's bits and pieces, those common building blocks that you see in Linux or in a POSIX environment that we would need if we're bringing software from those original execution environments to a WebAssembly execution environment. And we see a little bit of a shift in focus because we're looking at bringing in all that software as quickly as possible, and the component model folks, P2 and P3 and beyond, are really looking at cloud execution environments and just slightly different use cases, different application styles. So that's where we have a slightly different focus. That's why we set up the SIG, because we realized that there was a slight shift in focus, and then what can we do about that? So long-term support was an effort that started a couple of months ago, and we're trying to get everything together to understand what it really means. But in essence, it would mean having a supported compiler version, a supported WASI libc environment, a supported Rust environment, and we'd want to support that on a known released version of, for us, it's for WAMA. So is it a standard? Not in the traditional way at all. It's not. It's just effectively what you get from an LTS version of Linux. It is a baked-in, tested version of the runtime, the compiler, the toolchain, and the libc environment that all work together, that have been tested and known to work together, and that have longer-term support, so that when we deploy this and put that onto embedded devices, that we are sure that we will have a tool chain that we can use in the future that will generate WebAssembly that we can execute. And that's basically what we're trying to do. At the same time, we're looking at how do we grow the system interface space. There's things we need from Linux, of course, but or POSIX. There are other things that we need, like I2C interfaces or USB interfaces, which don't have the parallel yet in POSIX or Linux, but for which there are fairly well-known mechanisms to do this, and we can leverage those. So in the document I shared the link to, and I will very briefly just go through the high-level overview of the document on the call now, so you guys can see what I'm talking about, and hopefully this will all happen soon. Hit the share button again. There we go. So this document it's meant to be a little bit opinionated. just to drive conversation. It's very hard to argue about a blank sheet of paper, but if somebody puts down a strong view, you can have a strong response to it, and then we can have a conversation about what's right and what's wrong. So the content in this document is all up for discussion. Nothing's locked down, nothing's hammered into place. It's an open document for discussion so that we can come to alignment between ourselves on what we would need to do. So that's the first thing I say about the document, is that deliberately opinionated. If you think some of the opinions are wrong, too extreme, or not compatible with what you would need out of an LTS, just add a comment, correct it, or let's have that conversation. It's all here. That's why we're here. So I go through, the document goes through the key benefits, stability of an LTS, and then the software portability that the LTS will attempt to provide. And I've just talked about those. So stability in terms of everything works together. How long do we want to have that stability last for? Well, if we do a long-term release, we'd really like to have it for a minimum of 7 years. So that means bug fixes and security fixes and updates, but the API and that combination of this version of core WebAssembly, this version of WASI, this runtime version, all working together is kept for that period of time. And then software portability, how do we get practical and really, and essentially, one of the reasons why I keep coming back to POSIX and Linux is that most of the software that we imagine porting onto WebAssembly for an embedded environment comes from those origin execution environments. And the key here is just to reduce the cost. If you have to make significant changes to your code or significant changes to an open source project that you don't own, but you want to run it on your embedded system, well, that just pushes the cost up of adopting WebAssembly for the embedded space and for porting software to it. So we're trying to reduce those costs, and that's why you see things like we need a practical, low-cost way to bring existing software to the LTS WebAssembly platform. So we put in some key principles. Don't break the runtime. Learn from one release and apply to the next. So we want practical solutions rather than perfection, which is the next point. Try to solve the problem, be practical about it. There is this comment that portability is an aspiration, not a destination. We all know that in different embedded devices that control different physical pieces of hardware or operate different pieces of machinery will have different APIs and interfaces. And you actually won't be able to run, I don't know, I'm going to make this up. You won't be able to run a computer-controlled lathe software on a system that is not a lathe. It won't work. Or you can't run drill software on a lathe because the two don't work. Because it expects to find a drill, but it finds a lathe. So yes, we want portability where it's practical, but it's here we phrase it as aspiration, not a destination. Nothing can be portable everywhere. Code should be interoperable for sure, but when you get to that peripheral interface, yeah, kind of bound by what it has to do. So being practical about that. The other thing we say is for most of what the LTS is going to do to provide this stability, we're not going to rewrite WAMA, and we're not going to attempt to rewrite the Clang compiler or anything. So what we're actually doing is just inheriting code from parent projects and providing that validation and stability and support. And if we are modifying those parent projects, we modify those parent projects in exactly the same way as those parent projects are looked after today. So WAMA has a set of coding guidelines, a set of style guides. We follow that. We don't change that. We do this because we want to make sure that if we make a bug fix or a security patch, or we perhaps add a feature that we would like that WAMA doesn't have today, and we have a downstream version of WAMA with that in, well, if everything's aligned with the upstream version and the upstream would like it, we could offer it to them and they could take it as a very simple PR. So we don't need to reinvent the wheel. We just work with the parent projects. So this goes through the motivation. So today we have millions of devices installed with WASI Preview 1. and there are more still being produced. We have Preview 2 and Preview 3, and they continuing to iterate through how the software interfaces will work. And at the moment, as far as I'm aware, we have one runtime, WASM time with Preview 2 and shortly Preview 3 support. And in the embedded side, the runtimes we can use are all Preview 1. So when the embedded side, when we looked at the available runtimes, you have WASM to C, which technically doesn't have a system interface at all. You have WAMA, which has Preview 1. You could perhaps use Y0, but again, it's Preview 1. So for the runtimes that we're looking at for the embedded scenarios that we've got, it's Preview 1. So I already mentioned this synchronization between the tool chains and the runtimes, and this essentially goes through this in a little bit more detail, and it kind of explains why. When we talk about ROM versions and older hardware, and maintaining this support for currently deployed systems, and then how we assist software portability, what that's going to look like. Then we looked at how do you add extensions to, if we need to add extra functionality that isn't in Preview 1, how we do it. And we recognize that designing an API for new functionality is really, really hard, and you've got lots of scenarios to go through. But if we're talking about software portability, it's because we're porting software from an existing system that has an existing system interface. So let's be pragmatic and replicate that existing interface where we can. And then that means not reinventing APIs and looking to see what's available already. And for the software that we really want to support, what's the most common system interface look like, and can we use that? So that's basically it. So that's what it kind of goes through, and we talk about what we would want to produce. And here we get the artifacts that LTS will offer, or hope to offer, as quasi-libc, a Rust standard library, Rust-C, Clang compiler, and the runtimes WAMA and WASM-C. And then we go through what are the supported platforms. So I want to execute code. What would I execute? I want my runtime to execute on these platforms. So we separate it into development platforms and execution platforms. And here are the execution platforms. And we make a call to say we want to support these. So we've called out NutsX and Zephyr as the two embedded operating systems we're thinking about. We can add others. Like I say, it's just an opinionated first guess, and we went through and tried to talk to folks to ask them what operating systems they were using the most and what we should support. WAMA, of course, supports a whole wider list of these, so we can add them here. But in concrete terms, it would mean that if we do a CI/CD pipeline for WAMA, for libc, for Clang, and compiling WebAssembly, then what we want to do is make sure that CI/CD pipeline has test cases that validate each of these yeses. Each of these green boxes would have a validation step in it. So that's for WAMA. WASM to C basically works everywhere you can compile ANSI C, and the only dependency it's got is you can link against the math library, and it's because of that it's extremely portable. But there's no bare metal involved because it's transforming WebAssembly to C to be compiled natively. And in that case, we just need to run it on something which can compile C. So this is why you see a ISA, an operating system breakdown for WAMA, because WAMA needs to cope with those two changes. And in WAMA, we of course have the ahead of time compiler that needs to run as well. So all of that's here. So it's like, okay, if we're running WAMA on Zephyr, on an extensive platform, yeah, we want to make sure that the interpreter works, the fast interpreter works, the AOT works and the JIT works and all the interfaces work with it and all of that. So that's what these green boxes mean. For Wisdom to see, we of course don't have an interpreter or a JIT or a AOT because it generates C code. So we just need to compile the C and make sure that that functions equivalently. So the test cases for Wisdom to see are therefore one platform, an ANSI platform, run the tests, make sure everything works, and we're finished. So then we go on for tooling platforms, and there is some debate in some of the content here. So he said, okay, if you're going to run tooling, then it's a combination again of ISA and operating system. Because it's a development environment operating system, we broke it down to Windows, BSD, Mac OS, and Linux. And we said, was actually anybody doing any active development on BSD? And we didn't see anybody, but we left it in there with a no. So folks are, you say, hey, I really need to compile WebAssembly on BSD. We should fix that if that's the case. And we haven't heard anybody tell us to change it yet, but it's all open for debate and it's completely viable. Then you see the same thing with ARM and RISC-V. We haven't seen anybody using RISC-V as a development platform. Doesn't mean you can't, but if you'd like to, we should flag it here and get that done. And then assisting software porting, how that works. So it's against migration of software from Linux to the embedded system. And here we talk about being inspired by a WALI project, which came out of Carnegie Mellon. And that project was all about creating a Linux-specific system interface for WebAssembly to allow Linux applications to be cross-compiled easily to WebAssembly and run. It's a proof of concept. It's missing a whole bunch of stuff like security constructs are not in there. So we don't have a sandbox, but you can use it. It's an inspiration, which is why it's called out, not a design pattern exactly that we'd follow, but it just shows that it's possible to do that. And then if we ever needed to extend preview 1, we have Linux inspiration. Use the Linux Discord interface, and it provides a really valuable way to bring software over. And that's why we then talk about pragmatic portability and what that really means. And then, you know, when we look at what the component model is, it's really a foreign function interface binding mechanism. And that's great. It can have some advantages. Right now, there are some performance concerns that the embedded community have flagged. And I know that the component model team are working on and should be resolved. So then we say, okay, well, if we've got the component model coming up, could we migrate to the component model in the future? And actually, yes, we would. And what that would mean for us is those system level APIs, well, they don't change, the same system interfaces, the binding mechanism changes. And then fairness to our colleagues doing the component model work, they've also provided tooling that would allow you to automatically transform WebAssembly that doesn't use the component model binding mechanism to WebAssembly that could use a component model binding. So in the future, when the component model is ready for use in the embedded world, we should be able to come up with a migration strategy that allows us to move to it. But that's a future concern. At the moment, we're thinking one LTS for 7 years, provide the stability, provide some portability, and support the platforms that we really needed to, and more of a sort of near-term practical solution. And that is essentially the LTS, but the project documentation is up here for comment. There's already some comments on it, but waiting for a little bit more and to get back to people. And that is it for the LTS. I am done with that little talk through the document. I don't have anything else to talk about. What about you, Healing? Anything you'd like to add? If you're talking, you're muted, yeah?
Yeah. I don't have too much about the document itself, but I want to ask the status or if there is any action plan for those LTS.
Yeah, so first bit is to really see if we can get consensus on the LTS, which is we're getting there. And then the next bit would be to turn this into an action plan. What do we need to do to make this more concrete? And for that, it will be part of the reason why we go through detailing things like how we work with other projects is it provides the grounding for giving us all the information we need to generate a cost estimate for the participating organizations. What investment would it take for each of us to make sure LTS works and making sure that we can provide that? And so the next stage is once the LTS is documents kind of agreed, is to do what we were doing most software projects, and that's produce a high level task breakdown, a rough order of magnitude costing, and then we have the tasks which we can convert into GitHub issues, which we can then offer to folks to help with. So that's essentially it. So that task breakdown needs to be done.
Okay, so one more thing. When we said we need some approval or agreed on something, it's how much? I'm not sure how many stakeholders it's involved when we say we'll make it agreed.
That's a good question, and we've been waiting for a while. So, um, really, it's the you can't. It's a tough one, right? Don't want to exclude people, but can't wait forever. So it's time to kind of move forward, right? And so I think for us, it's in the SIG. We know we've representatives from Siemens and Schneider and
Mm-hmm.
Bosch and Intel and
Mm-hmm.
Sony and Xiaomi and others, and Amazon, of course, as well. So once we get majority sign off from those participants, those stakeholders, I think we're good to move forward. And I think we're almost there. I see some comments from folks who've done some embedded work on Preview 2, which is the University of Ghent.
Mm-hmm.
Merlin had some comments on that. So we should take those into view as well. But really, it's those major stakeholders, I think. And once we're good with those major stakeholders, we can then move on with this.
Okay,
So I
sign
think,
off. You mentioned a sign off. It's not a real sign off, right? It's just an agreement, or it's a real one.
yeah, it's we put it in there and we can vote on it and see if anybody wants to object to it.
Ah,
Right?
okay.
We could probably do that as well. Um, but it that would take if we finished off the comments in the document this week and we put it out, make sure that every time zone gets to vote and comment on it, then it's 6 weeks away before it's officially signed off. But in the meantime, we can start. If there's no major disagreements on it, and we're kind of majorly aligned, then it's just some details. But we can still move forward and do the task breakdown and start creating GitHub issues and get things set up for that. That's just some traditional project program manager work of going through and translating it. Bit mechanical effort, but it's not too bad. There will be some requests as we do that to the Bytecode Alliance, I think. If we're going to set up a CI/CD pipeline, it would be nice if we could get the support from the Bytecode Alliance to help contribute to those costs. I know they're doing it for the WASI SDK right now, so we should check in with them and see if we could do that too. I mean, ultimately we're going to need to. Help from Intel on that task breakdown would be really good because I know you guys have an amazing CI, CD, and test framework for WAMR and seeing what it would take to replicate that in a more public environment would be good too. So bits and pieces like this, I think we need to go through and pull out. Yeah, I think I keep hoping that we're nearly there. So I think now summer has been and gone, and people are back at the office. And vacation was a long distant memory. we can we can start um, thinking about putting some more effort into this and moving it along a little bit more. So yeah, so that's it from me.
Oh, by the way, Xing has already left Intel and he might start a uh new company. I don't know. And yeah, if you want to share some progress on news to the Walmart team, please forward one copy to me. Please.
Yeah, I heard that. I heard that. I'm just gonna pause the recording now.